Okay, so you're building something for the web. That's awesome. But we need to talk about something that's not just a feature, it's a fundamental promise you make to your users. And that promise begins with the most critical piece of data you'll ever handle, their passwords. Today, we're going to nail down that essential first step.
So, you've picked Go for your next web project. Great choice, by the way. But that brings us to the big question, the one you absolutely have to get right from the get-go. When a user trusts you enough to give you their password, how are you going to protect it?
Now, for the answer, we're not going to try to reinvent the wheel. We're turning to a fantastic, super practical resource, the Go Web Examples documentation. So think of this as our guide to their direct and, really effective approach to password security.
All right, let's dive into the core concept here. The security method we really need to understand is called password hashing. This isn't some fancy, newfangled idea. It's the industry standard way to handle user credentials securely. It's how the pros do it.
The most important idea to grab onto here is one-way process. Think of it like baking a cake. You can take flour, eggs, and sugar and turn them into a cake, but you can't unbake the cake to get the original ingredients back. Password hashing takes a password, scrambles it into this long, random-looking string of characters called a hash, and that's it. It's a one-way trip. You can never get the original password back from that hash.
So here's how it plays out in the real world. A user gives you their password. Your app immediately, and I mean instantly, uses a hashing algorithm to scramble it all up. And then, and this is the key, you only store that scrambled hash in your database. The original password is never ever saved. So if a hacker manages to break in, they don't get a nice list of passwords. They just get a bunch of useless scrambled hashes.
Okay, so that's the theory. But how do we actually do this in Go? Well, our source material points us to a very specific and really powerful tool for exactly this job.
And that tool is the bcrypt library. Now, here's the clever part. Normally, you want your code to be fast, right? Well, bcrypt is designed to be intentionally slow. And that's actually a massive security advantage because it makes it a total nightmare for an attacker to try and guess millions of passwords, what's called a brute force attack. It's an industry standard for a very good reason.
All right, enough theory. Let's get our hands dirty. What does this look like in an actual project? It's time to put all this into practice with the very first step you'll take in Go.
It all starts with one simple command. You pop up in your terminal and you run this: go get golang.org/x/crypto/bcrypt. You're basically just telling Go, hey, go grab that awesome security library for me. And just like that, it's downloaded and ready to use in any Go project you build from now on.
Now, once you have the library, the whole process really boils down to just two key moments. First, hashing a new password when someone signs up, and second, comparing that password when they try to log in later.
And here's exactly what that first part looks like. When a user signs up, you call a simple function like this. The magic is right here, and bcrypt.generateFromPassword. It takes their password plus a cost factor, that 14 you see, which is just how slow and secure you want to make it. And what it spits out is a secure hash that you can safely stick in your database.
Then, when that same user comes back to log in, you use the second key function, bcrypt.compareHash and password. This one securely compares the password they just typed in against the hash you have stored. It does all the heavy lifting behind the scenes. If it says they match, you let them in. Simple as that. That's the entire loop.
So we've got our code, but let's zoom out for a second. What does all this really represent? It's about so much more than just installing a package. It's about establishing a security-first mindset right from day one.
And that's the crucial point. Implementing these functions, that's step one. It's the foundational move you make on the path to building an application that actually respects and protects user data. Yep, it's simple, but it is absolutely non-negotiable if you want to build trust.
So, let's just recap the big takeaways. First, securing passwords is your job as a developer. It's on you. Second, password hashing is the standard way you do it. Third, if you're using Go, the bcrypt library gives you everything you need to do it right. And finally, putting this in place is the very first step you take toward earning your users' trust.
By putting this simple pattern into practice, you've officially set up your first and arguably most critical line of defense. You've laid the foundation for a secure and trustworthy application. So the only question left is, what amazing thing are you going to build on top of it?